This screencast refines the DistWu model from the previous video using a RadFrac model in Aspen Plus software. RadFrac is a much more rigorous simulator block that can model absorption, stripping, extractive distillation, azeotropic distillation, and reactive distillation. RadFrac can handle highly non-ideal components and can have multiple feed and product streams. Furthermore, RadFrac can differentially simulate a column with trays, random packing, or structured packing. In this screencast, we are going to use the parameters Aspen gave us for the DistWu model and refine them with the RadFrac model. To begin, open your DistWu simulation and go to your main flowsheet. Click on the column model block and delete it. Create a RadFrac model in its place and reconnect the feed and product stream. Press the green next arrow to enter information about the column. The calculation type will remain equilibrium. Input the number of stages from the previous simulation, 9. Choose a total condenser from the drop-down menu. The reboiler will remain as a kettle reboiler. Specify the distillate flow rate as 1,675.15 pound-moles per hour and a reflux ratio of 0.61. Both of these parameters were determined in the DistWu simulation. Pressing the green arrow brings you to the Streams tab. Recall from the DistWu simulation that the feed stage is 5.57. Distillation columns have the first stage at the top of the column and the nth stage at the bottom. Therefore, we want to specify the feed enters above stage 5. Next, input the condenser pressure of 1 atmosphere, or 14.7 psi. The RadFrac model allows you to specify information about the trays so Aspen can compute the column diameter and profile. Under Sizing and Rating on the menu tree, click on the Tray Sizing subfolder. Click New and proceed to the tray specifications. Enter the starting stage as 2 and the ending stage as 8. The first stage is a condenser, and the ninth stage is the reboiler. Choose the tray type as bubble cap and leave the tray spacing as 2 feet. On the Design tab, check your assumptions. The fractional approach to flooding is acceptable between 0.75 and 0.85. The minimum downcomer area as a fraction of the total tray area should be between 10 and 20%. The foaming factor is typically 1 for distillation columns. When all information is inputted, run the simulation. Click on Stream Summary and compare the results to the DistWu model. Under the Column Results block, note the condenser and reboiler heat duties. This also provides a mass balance and the split fractions of methanol and water. Notice how the distillate recovery is less for both components. This is due to the more rigorous model, which takes into consideration the non-ideal vapor-liquid equilibrium behavior between the two components. To view column design results, click on your tray sizing set and click on the Results tab. Here you can view the column diameter. Click on Profile to view how the diameter changes with stage. Notice how the results translate to a cone-shaped distillation tower. This indeed is what the stages look like inside a distillation column, but the column outer diameter is constant to provide structural integrity. Watch the following video in the YouTube playlist to see an application of Chapter 3, Separators, to a chlorobenzene production plant. For further Aspen Plus tutorials, visit the LafayetteChBE YouTube channel.